understand whether there is a prospect for electromagnetic fields to carry energy through completely empty space, I'd like to consider a particular possibility, a particular example of a phenomenon by which that might occur. And this is something known as a planar electromagnetic pulse. So I'm going to consider the possibility that the electric field vector, which of course in general is a function of all possible locations in space, so it's a function of x, y, and z. And if this thing is going to be traveling through space as some kind of a pulse, I have to allow for the possibility that these fields, the field also depends upon the time t. And but when I talk about a planar pulse, in particular, I'm considering the possibility that the electric field, which in principle is a function of all four of these coordinates, to kind of simplify our math for ourselves right now, we're going to imagine that, in fact, this thing is traveling somehow, let's say, along the x direction, so that we're going to consider the possibility of a function that really depends only on x and time t. So that what I'm really saying is that this function here is constant for all possible values of y and z. If I make a sketch of a standard right-handed coordinate system, I'm saying, this here might be my x coordinate, here is my y coordinate going back into the plane, and my z coordinate going up the page. And what I'm saying is that if I have an electric field value at any location here, say, I can pick a particular value of x, and I consider a plane here. This is where the name planar pulse comes from. What I'm saying is that if the electric field vector has some value in this plane at a given time with some length and some direction, notice that for any point in this plane which has the same exact value of x, because this plane is defined by all those points which have exactly the same value of x. Let me make the sketch look a little more like the plane. Here you can't really see behind this axis, so it should go like this. A little better three-dimensional view. What I'm saying is that the electric field at all points here in this plane have exactly the same direction and the same magnitude. So because the field is precisely the same at all points in a plane, that's why we describe this thing as quote-unquote a planar pulse. Now, you'll notice that what I've done is I've chosen this x direction as some special direction. In general, I could have a pulse traveling along any direction, but because we're always free, of course, to choose whatever coordinate system we please, basically I'm going to define my coordinates in such a way that, in fact, the direction of motion of this pulse is actually going to be along the x direction.